Newton's three laws of motion are one of the most important and influential concepts of physics. But did you know that these laws are crucial in developing efficient spacecraft traveling the cosmos? Newton's first law of motion states that an object at rest will remain at rest, and an object at motion stays in motion with the same acceleration, unless acted upon by an unbalanced force. This is also known as the law of inertia, which is just a fancy word for wanting to remain in its state of motion. This can be seen when a skydiver jumps out of an airplane. To overcome inertia, the skydiver's weight or gravitational force must be greater than the force of friction, which in this case is air resistance. This causes the skydiver to accelerate, in other words, change its speed and/or direction. However, when the skydiver opens his parachute, his weight balances with the now greater air resistance. The skydiver has now reached terminal velocity and no longer accelerates. Newton's second law states that the net force of an object equals to its mass multiplied by its acceleration. Alternatively, the acceleration of an object is directly proportional to its net force and inversely proportional to its mass. This gives the equation F equals ma, which is one of the most famous equations in all of physics and can be used in numerous different scenarios. This can be demonstrated through throwing a ball up in the air. When the ball begins to fall to the ground, it is being pulled by the force of gravity, which causes it to accelerate downward at approximately 9.81 meters per second squared. If the mass of the ball is 2 kilos, to calculate the force of gravity, you would need to multiply 9.81 meters per second squared by 2 kilos to get the force of gravity on the ball, which in this case is 19.62 newtons. Finally, Newton's third law states that for every action, there is an equal but opposite reaction, which can be expressed by the equation F1 equals to minus F2. This law is often the most confusing of the three. A simple example of Newton's third law is what happens when you punch a wall. When your fist comes into contact with the wall, you apply force to it. The wall then applies a force back on you with the same magnitude but in the opposite direction. This force is called the normal force. When a rocket is preparing to launch, it is at rest, and due to the property of inertia, it wants to stay at rest. To accelerate off the ground, the rocket must produce an unbalanced force to overcome inertia. This unbalanced force will be explained later by Newton's third law. When a spacecraft travels in the vacuum of space, no unbalanced force is needed to propel it forward. This is because it is already in motion and will stay in motion due to inertia. There is no unbalanced forces such as air resistance to change the acceleration of the spacecraft. The spacecraft will continue to glide endlessly until it collides with another object. Newton's second law is used when designing efficient rockets. In order to calculate the amount of force produced from burning rocket fuel, F equals ma is applied. The first factor in determining force is the total mass of the rocket. As stated in Newton's second law, mass is inversely proportional to force, which means that the less mass you have, the greater your force. For every action, there is an equal and opposite reaction. Newton's third law is possibly the most crucial physics concept for space travel. Why? The third law describes why the rocket gets propelled when it expels gas. This can be a very difficult concept to grasp in rocket science, so we can simplify it by using this question. In space, how does rocket fuel propel rockets when the fire has nothing to push off of? There is a common misconception that rockets push against air to propel forward. Well, if rockets push against air to propel, they wouldn't be able to function in space. Therefore, this can't be the way rockets work. The way rockets really work are that particles are released at extremely high velocities at the rocket's nozzle. Each of the gas particles being expelled has a force applied to it, but there is also the equal and opposite reaction that is applied to the rocket. This reaction force propels the rocket forward with the same magnitude of force as the propellant. In conclusion, Newton's laws plays a vital role in space travel. Without them, it would be impossible to work out the necessary calculations for interstellar travel. To sum up, Newton's first law states that spacecraft must overcome inertia to lift off the Earth. Newton's second law is important in calculating the amount of force required for spacecraft to launch and maneuver in space. Newton's third law explains how rocket propulsion works through action-reaction force pairs.